Okay, guys, so I think we can start it again. Sorry for the interruption. There was some internet issue. I think this is now resolved. So again, you can join. It's my request, guys. Please join again so that we will be able to start this session. Okay. As you know, guys, we are solving some questions from VCRS cycle for upcoming HAL examination. Yes, sorry for the interruption, guys. I can understand. Yes, you face some kind of difficulty due to internet issue. Okay. So let's start it again, guys. This is the first question we are solving, statement 1, statement 2. So what I mentioned, guys, the COP of a refrigerator, like suppose if I will give you a domestic refrigerator that is going to perform well in the winter as compared to in summer. So in summer, your cost of economy will be less. Your cost of using that refrigerator will increase. Why? Because in summer the temperature difference between evaporator and the condenser, means outside temperature, is higher, and due to high temperature difference, the COP of your domestic refrigerator will be lower in summer, and COP of the domestic refrigerator will be higher in winter. I think you got the point. So these things you need to know, like how we can increase the COP of a refrigerator. By increasing the evaporator temperature, by decreasing the condenser temperature, we can increase the COP. Okay. And these two statements also, I think you got the point. Next question, guys, in front of you, this is question number 2. Let's try to answer this also. Question number 2. Okay. So please try this question number 2. Okay, chaliye. The following data refers to a vapor compression refrigerator, VCRS system. Enthalpy at compressor, this. Enthalpy at compressor, inlet. This is enthalpy at compressor outlet. Enthalpy at condenser outlet. He is asking you the COP. Very typical PSU question, guys. बहुत बार इस तरह के क्वेश्चन पूछे जाते हैं, and you need to solve these questions very easily. You can solve. If you draw here the cycle diagram, guys, let me draw here TS also, or you can draw PH also. Okay, so TS diagram will be something like this. TS diagram will be something like this. Okay, like this is 1 to 2. You can show it here. This is isentropic compression in the compressor, then constant pressure heat rejection, then isenthalpic expansion process. So the cycle will be something like this: 1, 2, 3, 4. Okay, 1 to 2 isentropic compression, 2 to 3 constant pressure heat rejection, 3 to 4 isenthalpic expansion in the throttling device, 4 to 1 is a heat addition in the evaporator. Okay, so here if you will write enthalpy at the compressor inlet means H1. So H1 is given to you. This is nothing but H1. This is nothing but H2. Okay, this is nothing but H3 equal to H4. Why? Because in case of VCRS system, 3 to 4 is the expansion process in the throttling device, and in throttling device, guys, expansion is taking place isenthalpically, means the enthalpy remains constant in that expansion in the throttling device. Okay, so throttling is an isenthalpic process. That's why H3 equal to H4. Okay, so now if you want to find out COP of a refrigerator system, COP of refrigerator is nothing but refrigeration effect produced divided by W in. Okay, so what is refrigeration effect produced? How much heat you are picking. So heat picked is equal to what? H1 minus H4. The change in enthalpy in the evaporator, this is the refrigeration effect. Okay, Wn is nothing but H2 minus H1. Now if you will put all values, you will get the answer. What is H1, guys? H1 is 1200. H4 is this is H3, H4 200 divided by H2. H2 is 1400 and H1 is 1200. So 1000 divided by 200, you will get 5 as the answer, COP. So option C is the right answer, guys, for this question. I hope this question is very much clear to all of you guys. Very simple question. Yes, Ritesh, your answer is right. Option C, 5 is the right answer for this question. Okay, तो बहुत बार इस तरह के क्वेश्चन पूछता है बच्चों. Through this question also we are getting the idea, like what is the role of evaporator temperature, what is the role of condenser temperature. You know, guys, in VCRS system, what is the principle of VCRS system? Then people ask you, like any interviewer ask you about the principle of VCRS. Lots of students, they start explaining about the working. Principle is what means in refrigeration. How we produce refrigeration in VCRS? By boiling the refrigerant in the evaporator. And what is a unique thing in VCRS? You are carrying out boiling at low temperature, because in the evaporator you are having low temperature, and you are carrying out condensation at high temperature. Like it is slightly different. Boiling at low temperature, condensation at high temperature. How? Just by maintaining the pressure. Because when we increase the pressure of a refrigerant, its temperature, saturation temperature increases, means its boiling point increases. When we compress a refrigerant at high pressure, its boiling point increases. That's why we are able to condense the refrigerant at high temperature, and due to suction created by the evaporator, the pressure decreases, the boiling point T saturation decreases, and that's why we are carrying out boiling of the refrigerant at low temperature, evaporator temperature, and condensation at high temperature. That is a principle of ECRS. So if anybody will ask you what is the principle, that thing you need to explain. But most of the students, they say, sir, refrigerant start moving from evaporator, something like that. That is not right. Okay, chaliye. So this is second question, guys, in front of you. Okay, third question. This is question number third in front of you guys. Okay, the compressor of a ammonia refrigerating machine has a volumetric efficiency of 85%. So the volumetric efficiency of the compressor is 85%, means this. And what is volumetric efficiency, guys? This is nothing but actual volume entering into the compressor divided by maximum volume intake. Actual volume intake divided by maximum volume intake, or you can write it as actual mass flow rate entering divided by maximum mass flow rate entering. Okay, something like that. Actual mass flow rate divided by maximum mass flow rate. Okay, so now he has given you the volumetric efficiency. The swept volume is also given to you. So this is swept volume. Okay, this is what? This is maximum volume flow rate. V maximum volume flow rate is nothing but V swept. So this is given to you 0.85 meter cube per minute. So from that, easily you will get actual volume intake. So what is actual volume intake? It is nothing but 0.28 multiplied by 0.85. So this is actual volume intake. Yes or no, guys? Now you want what? Mass flow rate of the ammonia. You want actual mass flow rate. Actual mass flow rate of the refrigerant, where the dryness fraction is 0.7. So slightly difficult question, slightly different also. So here the specific volume we are having, actual volume we are having this. Okay, in unit will be what? Units will be in meter cube per minute. Okay, meter cube per minute. So he is asking you mass. Okay, mass flow rate. For that you need to divide it by what? आपको इसको किससे divide करना पड़ेगा? Specific volume से. So this is volume flow rate. Actual volume flow rate you are having in meter cube per minute. This, if you will divide it by the specific volume, you will get the answer. But from where you will get the specific volume, guys? Specific volume. This is specific volume. Note it down, guys. This is volume flow rate. It is better to write here V. मैं यहाँ V लिख देता हूँ, so that you will get you will not be confused between this and this V and this V. So this is volume flow rate actual. This is volume flow rate maximum. And let me here also write capital V, so that you will get idea. Okay, chaliye. So let me write it here. V max equal to V swept. Okay, this is this. So this is V actual. Okay, so now swept volume, this is V actual. So what is specific volume, guys? In specific volume in the wet region, you can write it as Vf plus X VFG. Yes or no? Or you can write it as Vf plus X into Vg minus Vf. Okay, so Vf is not given to you, but you know the specific volume of the liquid refrigerant is negligible. Liquids are what? Liquids are having high density as compared to density of gases, and specific volume is nothing but it is a reciprocal of density. So the specific volume of liquids, this is very, very small. Okay, this is very, very small. So we can neglect that. इसको हम क्या कर सकते हैं? Neglect कर सकते हैं. So if you neglect this, so you can write V specific volume is equal to X times 0.7 into Vg. What is Vg? Vg is given to you. If you will check it here, the dry specific volume is this. Dry specific volume. Dry specific volume is Vg. He's talking about the saturated volume of a gas. So 0.7 multiplied by 0.25, you will get this V. Okay, now what you need to do, guys? You need to divide this V actual divided by V, because this is in meter cube per kg and this is in kg per meter cube. Okay, kg per meter cube. Sorry, this is in meter cube per second. This is in meter cube per second. Okay, and this is in kg per meter cube. So let's check what unit you will get out of this. इससे क्या unit आएगा? Okay, we want what, guys? We want mass flow rate. Let me write it here also. Mass is nothing but, density is nothing but mass per unit volume. So density equal to mass per unit volume, or mass equal to density into volume. So mass flow rate equal to density into volume flow rate, or this is equal to density, or what you can say here, you can write it here, volume flow rate divided by specific volume. Okay, so this is the reason I'm writing mass flow rate equal to volume flow rate divided by specific volume. So here we want mass flow rate, so this is equal to volume flow rate. What is volume flow rate, guys? 0.28 multiplied by 0.85 divided by specific volume 0.7 multiplied by 0.25. So you need to solve this, guys. If you will solve this 0.4, you will get the answer. So try to solve this so that you will get the mass flow rate. तो इसको solve करो बच्चों, you will get the answer. Okay, Please try to solve this so that you will get the answer. Yes. इसको इस पे करेंगे तो हम 20 पे जाएगा, 20 2 32. ओके, लेट मी राइट इट हियर. मैंने यहां पे थोड़ा सा गलत लिख दिया. सो दिस विल बी 0 2, then 32 4, then it will be this, something like this. So check it out, what answer you are getting. Okay, check it out guys, what answer you are getting. You need to solve this. Isko solve karo aap. You need to solve this. Okay, because I divided this by this, and just solve it. What answer you are getting? 0.4 multiplied by 0.85 divided by this 0.25. So tell me what answer you are getting. Yes, please confirm. These are the four options available: 1.28, 1.36, 1.42, 1.57. Please tell me what answer you are getting for this question. Okay, getting any answer guys? Yes, so the answer for this question is 1.36. Okay, 1.36 is the answer for this question guys. 1.36 kg per minute. Okay, so this is the answer for this question. I hope you got the idea guys. So initially first I solved for the volumetric efficiency. From volumetric efficiency I got the actual volume intake. From actual volume intake, because maximum volume intake is given to us, because maximum volume intake is sweat volume, from that initially I calculated the specific volume, neglecting the VF, because VF is very less as compared to VG. So we got V, and then I divided actual volume intake divided by specific volume to find out the mass flow rate. Okay, so I hope this question is very much clear to all of you. Let us move to next question, question number 4. So this is question number 4 guys in front of you. There are two statements. Statement 1, subcooling of a refrigerant liquid increases the COP. क्या subcooling से COP बढ़ता है बच्चों? Subcooling of a refrigerant liquid increases the COP, coefficient of performance of a refrigerator system. Yes, this is right. Subcooling से बच्चों, subcooling increases the refrigeration effect. It increases the COP. Okay, but W compressor remains same. WC क्या रहता है बच्चों? W compressor remains same. So it is not going to affect compressor work. But when you are carrying out the subcooling, COP will increase, refrigeration effect will increase, compressor work will remain same. Okay, if you are carrying out superheating, okay, superheating, so then there are chances, if you are carrying out superheating in the evaporator, then your COP, refrigeration effect will increase. Your COP can increase or decrease, it depends on the refrigerant. But if you are carrying out superheating in the evaporator, definitely your refrigeration effect will increase, but at the same time your compressor work will also increase. Okay, so due to superheating, compressor work will increase. COP may increase or decrease, it depends on the type of refrigerant. So I think these things are very important guys for refrigerator. Subcooling, refrigeration effect increase, COP increases, compressor work remains same. Superheating, refrigeration effect increases, compressor work increases, COP may increase or decrease, it depends on the type of refrigerant. For ammonia, it is observed COP decreases, and for some refrigerant like R11, R12, COP increases. Okay, chaliye, so this statement 1 is fine, right? Let's read about statement 2 also. Subcooling reduces the compressor work, which is wrong. Subcooling is not going to affect the compressor work, so only statement 1 is right. So that's why option C is the right answer for this question. Is it fine guys? Ritesh, please check. B is not right, C is the right answer. Why? Because statement 2 is wrong. Four options are what? Option A, both statements are right, they are related. Option B, both are right but they are not related. Option C, only one is right, two is wrong. And option D, one is wrong and second statement is right. So in this case, as we can observe, statement 2 is wrong, so option C is the right answer. Got that idea guys? Please confirm. Chaliye, let's move to next question, question number 5. The ordinates and abscissa of the diagram given for the vapor compression refrigeration system. So earlier in question number 1 guys, I have drawn here the TS diagram for VCRS cycle. Okay, similarly here, what do you feel? This is what, like PV diagram, pH diagram, or what? There are different options given: pressure, volume, temperature, enthalpy, enthalpy, entropy, pressure, enthalpy. So as you can observe it here guys, this is nothing but a expansion process, expansion in the throttling device, and you are having a vertical line. So it means this is a isenthalpic process. So in this line you will have what? Enthalpy. यहाँ पे क्या मिलेगा आपको? एंथैल्पी. Similarly, here you can observe two horizontal lines. Okay. And what is this? This is a heat addition in the evaporator, heat rejection in the condenser. Heat addition in the evaporator and heat rejection in the condenser takes place at constant pressure. So in VCRS system, we are having constant pressure heat addition, then isentropic compression, then constant pressure heat rejection, then isenthalpic expansion. These are the four processes in VCRS system. So that's why this is nothing but pH diagram. ये कौन सा diagram है बच्चों? pH diagram. Okay, so for pH, this curve you need to draw slightly like this. Okay, for TS we are having a kind of symmetrical curve. For pH we will have a curve something like this. Okay, something like this. So pH, pressure versus enthalpy diagram, and this curve will be something like this. Okay, something like this. So what we are assuming, guys? We are assuming at the exit of the evaporator you are having saturated gas, at the exit of the condenser you are having saturated liquid. These 2 points we are assuming. This is exit of the entry of the compressor or exit of the evaporator. This is exit of the condenser or entry of the expansion device. So these 2 points are fixed in a standard VCRS system. Okay, so pH diagram means option D is the right answer. Let us move to next question, guys. Question number 6. In the working of VCRS system, the following enthalpies are recorded at silent points in the cycle. So similar kind of question, guys. Earlier also we have solved this kind of question. So please try to answer. Enthalpy at the inlet of compressor, something like this. If you draw the pH diagram here, something like this. So these are the different points on pH diagram. Okay, so you can mark it here 1, 2, 3, 4. Okay, these are the 4 points. So now if you will mark it here, what is this? Enthalpy at the exit of the compressor, inlet of the compressor means this is okay. This is point 1, enthalpy at the inlet of compressor. This is enthalpy at the exit of the compressor. So all enthalpies are given to us. H3 equal to H4 because 3 to 4 is isenthalpic process. So COP is nothing but refrigeration effect produced divided by compressor work H2 minus H1. So only you need to put the given data and you need to enjoy the answer. So H1 is nothing but H1 is given to you 300 minus H4. H4 is this 150 divided by H2. H2 is 330 minus 300. So 150 divided by 30, again 5 is the answer for this question. Okay, option C, 5 is the answer for this question, guys. COP 5. Let's move to next question, question number 7. Consider the following statements in respect of the vapor compression unit. Vapor compression unit के favor में what are the statements which are right actually? VCRS system. In actual units, the refrigerant leaving the evaporator is superheated. Superheating of refrigerant at the exit of evaporator increases the refrigeration effect. Superheating of refrigerant increases the work of compressor. So what do you feel, guys? Out of these statements, which statement is right? All are right? 1, 2, 3, or only 1, 2 is right? 1, 3 is right, or 2, 3 is right? Yes, please try to answer this question, guys. Please try to answer this question. What do you feel? When you are carrying out superheating, so superheating in the evaporator, generally we allow the superheated refrigerant so that superheated refrigerant will come out from the evaporator, so that we will be able to ensure no liquid entering into the compressor, because if liquid is entering into the compressor, that can damage your compressor. Okay, so we cannot allow liquid to enter into the compressor. That's why always it is recommended to have some kind of superheating at the exit of the evaporator or before the entry of the compressor. So this point 1 is right. Okay, similarly when you are carrying out superheating, so the refrigeration effect will increase. This is also right. Superheating increases the compressor work. That is also right. Guys, WC compressor work is nothing but this you can write it as minus VDP. इसको हम क्या लिख सकते हैं? This you can write it as minus VDP. Okay, minus VDP. Okay, इसको हम ऐसा भी लिख सकते हैं. This you can write it as something like this also, minus N by N minus 1 into P1 V1 minus P2 V2. Okay, या इसको आप लिख सकते हो minus N by N minus 1 into P1 V1 which is MRT1 into 1 minus T2 by T1. So 1 minus T2 by T1 you can write it as P2 by P1 की power gamma या N minus 1 by N. Okay, so this is how you can write. This is how you can write this. Are you getting this idea, guys? This is how you can write this. Okay, so I'm removing this bracket. So as you can observe, when you are carrying out the superheating, so the compressor entry temperature T1 increases, guys. When you are carrying out the superheating, exit and inlet temperature of the compressor T1 is going to increase, and more is the T1, more is the compressor work. So what you have to understand, due to superheating, inlet temperature to the compressor, inlet temperature to compressor increases. Okay, inlet temperature to compressor increases, so that your W compressor increases. I hope this is clear to you. Let us now move to question number 8. In a VCRS system, so guys, for this question, all three are right. Option D is the right answer. Option D is the right answer, guys, for this question. Not 1 and 3. Okay, 1, 2, 3, all are right. VCRS system, the total heat rejected in the condenser is this. So how much is the heat rejection, guys? Heat rejection equal to 1500 kilojoule per kg. This is heat rejection. Work done in the compressor, WC, is 250 kilojoule per kg. Now he is asking you the COP. Again, very simple question. So COP is nothing but refrigeration effect by W in. Refrigeration effect is nothing but heat rejection minus WC. Rejection equal to refrigeration effect plus WC. Heat rejection in the VCR system, guys, is always more than heat addition. So whatever heat you are adding plus compressor work, that is equal to heat rejection in VCR system. So refrigeration effect equal to rejection minus compressor work divided by WC. So rejection is given to you, WC is given to you. Easily you will get the answer. 1500 minus 250 divided by 250. Again, you will get the 5 as the. I think 5 is their favorite number. You know? In year 1917, I think this was asked in, I don't know, 17 or 16. So these previous year questions they asked, and I think 5 is their favorite number. Okay, because 3 times we solved these type of question. COP, although data is different, but every time we are getting COP 5. Okay, so this time also we are getting COP 5. Chaliye, I hope this is very much clear to all of you guys how we are calculating the COP. Let us move to next question, question number 9. Consider the following data referring to a refrigerator working on vapor compression refrigeration system. So again, some data is given. He's asking you the COP. Now, guys, it's my request. Please try to answer. अभी मेरे को बहुत ज़्यादा अच्छे आंसर आपसे मिल नहीं रहे हैं बच्चों. You are not answering actually. So please try to answer these questions. Enthalpy at the entry of compressor, I'm writing it as H1. Now you need to solve it in your mind. There is no need to draw the diagram. Enthalpy at the exit of the compressor, this is H2. This is H3 equal to H4. So he's asking you the COP. So COP equal to refrigeration effect. Refrigeration effect is nothing but H1 minus H4, okay, divided by H2 minus H1. So what will be the answer, guys? H1 is what? 180 minus 60 means 120 divided by 210 minus 180. Okay, so 120 by 30, you will get 4 as the right answer. So COP 4 is the answer for this question. For this question, now we are getting COP 4. Is it fine, guys? Is it fine? Please check. I think this time there is no need to draw that TS or pH diagram. Okay, so you need to think. This is the compressor. This is isentropic compression. This is isenthalpic expansion. Something like this. So the cycle is something like this. Okay, and these are the different points mentioned. 1, 2, 3, 4. Okay, these are the 4 points I'm showing here in pH diagram. Okay, chaliye, let us move to next question, question number 10. In case of vapor compression refrigeration, if the condenser temperature of the refrigerant is closer to the critical point, guys, like if I'll draw it here, TS diagram or pH diagram, anyone. So if you will draw here TS diagram, and he's saying the condenser temperature is very close to the critical point. Okay, so in general case, the cycle diagram is something like this. This is the cycle diagram on TS diagram, something like this. Okay, so this is point 1, point 2, point 3, point 4. 1 to 2 isentropic compression, 2 to 3 heat reaction in the condenser, 3 to 4